Good evening and welcome to the January 2022 BTS lecture. So this evening, our lecture is on small steps forward in sustainable sprayed concrete tunnels. And this is tonight we have Dimmock, who is the Vice President Tunnelling Normet Group. So Ross is well known to both the UK and international sprayed concrete industry, having started his journey on the Natham sections of the Channel Tunnel. Before joining Normet, he followed two separate episodes in Mott's working on Crossrail and Hindhead, between which he worked for 𝗦𝗲𝗿𝗍 on the Waterloo Station Jubilee line and the MBT, later BASF, globally. After 11 years with Normet, he is now their Vice President for Tunnelling and has the exciting challenge to develop sustainable, low-carbon solutions for the industry, pulling on his 33 years of sprayed concrete tunnelling passion and motivating change. Welcome tonight, Ross, and thank you for joining us.
Thank you, Kate. Thanks very much for that introduction. And yeah, it's a shame I really couldn't get so nervous in the ICE building in front of all our learned friends. And but it's bad enough sitting behind a screen. But we're all pretty used to it. And yeah, I think tonight is really an interesting topic for me and hopefully for the audience. And in my usual style, everything is picture based. It's something I did as a kid. I didn't like writing; I just liked looking at pictures. And I think for presentations, that's not a bad way forward. So hopefully, I know it's the evening. Hopefully, I can keep people awake and interested. And I think it would be interesting to get feedback and ideas at the end, because it's my view. It's not written in stone. This is a new topic, and I think there's still a lot of questions I'm sure a lot of people have about it. So let's get started. Hopefully everything is functioning as it should. So setting the scene for this evening, there's sort of 5 areas that I'm going to briskly whisk you through. One is like an introduction to what I call my sprayed concrete lining sustainable influencers, sort of like a social media influencer, if you like. And then I'm going to talk very briefly about where we've been in sprayed concrete tunnelling in the UK. And how that really sets us on a good footing, I believe, for a low carbon future and how we can develop it. Then I'll briefly mention through examples really from Norway about SCL and its role in providing sustainable projects actually. And I think then the final question really is how we turn these little steps of sustainable tunnelling into bigger steps, and the things that we need to consider. And throughout the talk, I'll pull on a sort of experience that I have within my colleagues and areas that Normet are very sort of engaged with, and that's in Norway, and some of the good things that are going on there, which might be quite good for you guys to see in the UK. So, what would be a presentation without the word COVID in it? And I'm sure if you're anything like me, you're pretty sick and tired of these little plastic strips and sticking things up your nose and down your throat and squirting bits of fluid into tubes and things like that. And it has been quite horrendous, I'd imagine, for everybody. But there are some good COVID positives, as I call them. And really, I think during that lockdown, during those times, I think we had a glimpse of an environment that we found quite pleasing. Very low traffic, very clear skies, and satellite images on the news of northern Italy looking smog-free, and in India. And I think it was quite an eye-opener, I think, and how quickly we felt the climate could get back to normal, or back to some kind of clean regime. Anyway, I think the other thing that that I think was interesting was the amount of collaboration and the behaviors, human behaviors in collaboration to actually achieve a goal. on a massive scale, of course, and a real challenge to the industry, in the medical industry, to produce vaccines. But it shows that things can really work globally and collaboratively on real issues. I think the other thing was that we started to create corporate, and our own personal behaviours may have changed. I don't know how it is in your organisations, but I think a caring side has sort of emerged, and certainly in the last year, the discussions in Normet as an example of our industry, has been about care, commitment, courage. It's been about really looking at sustainable topics, and we got involved with some consultants about looking how we could do better, and they're saying this is a magnitude change from pre-COVID in the need to develop these sustainable approaches to our working lives. And I guess all of us know about Zooming and unmuting. And again, tonight, I forgot to unmute my button. So I think we all know where it is, but don't know how to use it. All right. So going right from a big high level view of sustainability and where we're going with this talk tonight, I really like this idea. We're hearing in the news this idea of the Paris Accord. What the goodness me is that? What has that got to do with shotcrete tunnelling in London or in the middle of the UK? And this plan was written in 2015, and it was signed off in 2016 by all these super world leaders. And of course, Trump pulled out, and I think there must have been a collective sigh of relief when John Kerry and his granddaughter rejoined on behalf of the US to the UN. But that's all great, and I love this photograph of these leaders of the UN smiling and thinking, thank goodness, we've got everybody back on track again. So I really take pleasure in looking at that one particular photo. But what does it mean? What does it mean for us in tunnelling, and how do we convert these sort of UN and these Paris Accords and COP26 in Glasgow into what we're doing? And there is a lot of talk, there's a lot of media discussions and a lot of politicians talking about low carbon and sustainability. And the UN, they love their icons, and under the Sustainable Development Goals, there's plenty, 17 of them to look at. And what we're doing in Normet, not to be outdone by the UN, we've created a hell of a lot more icons as well. But they really fall into three areas. It's about the planet, the environment, it's about people, and it's also about policy and the way we conduct ourselves. But tonight, I really don't want to talk about all these sustainable topics. But a key one is obviously carbon emissions, and having a low carbon tunnelling approach. But actually, in those sort of planet topics that we're all engaged in, and I'm sure these sort of policies and these sort of approaches to sustainability are common as they would be in designers, as they are in contractors and client teams. And it's just maybe different emphasis on them. But I'd like to talk about carbon in terms of my sustainable SCL talk tonight, really about carbon emissions. I know Kate remembers this, but we had a really interesting, it was quite stimulating for me really to be asked to join the committee, BTS committee, on a special meeting with Rachel Skinner. And I was really I was left with quite a strong message from her. She is a champion of low carbon in infrastructure, and we were asking her about what the impacts would be for tunnelling and what she thought about it. And I remember one statement. She said there are two strategy buckets I consider with infrastructure, and that's the attack bucket and the defence bucket, right? And I thought that was interesting. And for her, the attack bucket was really about, keeping our carbon emissions low, as low as we can to keep within this Paris Accord and towards net zero by throwing all the tools in our armory at reducing carbon, like low carbon concretes, digitalization, electric construction vehicles, and the like. And the defence bucket was a little bit more troublesome for me. And I'm not going to go talking about it any more than this slide, because if you remember in 2021, in the middle of the summer, there was this massive rainfall, 270 millimeters of rain in a few days. And it flooded most of Europe, including London. And a lot of the infrastructure, or our tunneling infrastructure, things that we get passionate about, we were a bit dismayed to see these images. And it's not just Europe. I mean, there's Singapore, New York, Germany, London, Czechoslovakia, Poland, all had massive flooding issues in their tunneling infrastructure. And Rachel Skinner's view was, we need to think about that when the attack strategy hasn't maybe quite done it. We need to consider climate change on tunnels and in new tunnel design, but also in the existing infrastructures we have. What can we do to protect them in the future? I don't have an answer. It left me a bit flummoxed, but it is one of those topics that we need to think about going forwards. My other influencer, and I have to recommend this chap to you, is 𝗦𝗲𝗿𝗲𝗿. He works for 𝗦𝗽𝗲𝗍, a designer based in Glasgow, but he's also representing low carbon in infrastructure for the Scottish government, the Welsh government, I think the Irish government, and I think he's been doing some work for England. I'm sorry. He's also the ICE tutor for carbon management in infrastructure, and I recommend to everyone to go on that course. It is absolutely superb, and really opens your mind to the ideas of where we're going with carbon, not just about talking about it, but actually implementing carbon management routes to actually implement in our projects. And his view is, on the projects that he has been involved in, is that carbon saving equals cost saving. And of course, that's music to everybody's ears. Not everybody believes it, but he is pretty convinced it is. Because his view is, if you start monitoring carbon, you actually start monitoring costs and material usage. So it's quite an interesting concept. I really recommend anybody who's interested in carbon reduction to book onto this ICE course. And he's running, I think, 4 or 5 a year, depending on how many are coming in, I guess. He's also won awards with 𝗦𝗽𝗍𝗍 for creating a carbon group within 𝗦𝗽𝗍𝗍. So within his organization, they have an actual team dedicated to carbon management. And I wonder how many organizations out there have that in their team. My other pin-ups, all right, I was going to call pin-ups, but I call them heroes. And there are a lot, and these are just 3 I could think of in particular related to sustainable SCL. Is, well, of course, Tom Melby. I don't know how many of you know him, but in our industry and globally, he's extremely well known. I've probably known Tom for 25 years. And a lot of the spraying technologies, the Supremas, the Mako equipment that you see around, and the Normet kit that you see around, and all the spray membranes and microsilicas in concretes and fibers all come really from, in a way, this guy. I mean, he's brought a lot of this technology to the industry. And even now, he's refused to even go in cars and trains. He's actually, skiing everywhere and saving energy. No, that's not true. And electric bikes as well and things like that. But he remains quite an inspiration in how we develop our industry. And I think the other one then is Keith Bowers, and the Harding lecture a few years ago was actually very stimulating. And I know Keith from a long time ago, since TRL days. And I know that the project that he's working on now are addressing these things very seriously and really moving in a good direction, even to the point of producing their own energy to drive equipment on site using electrolysis of seawater to make hydrogen. So really inspirational characters that we need in our industry. And then Dr. Alan Thomas. Alan is, known since Crossrail times, right at the beginning of the design. We continue to discuss these things, but I think what Alan has done is, particularly with spray concrete, he started to put numbers and break down where the carbon is. And I find that, that's really been quite useful for us in Normet, looking at the way we develop this and look at things that we need to do to get it right. So really these three guys, I could put more 𝗦𝗲𝗻𝗲𝗿 and others into this picture frame, but I can't have too many heroes on one page, Kate, So 𝗦𝗲𝗻𝗲𝗿 Wallace and me, remember this long time ago in 𝗦𝗻𝗻𝗲𝗿, spraying membranes on this massive road tunnel. I'd like to just take you back a little bit. I think it's good sometimes to know where we've come from in order to know where we're going to go. So this is a very short story. My apologies go out to all the people I don't include and the projects I don't include, because there are so many fantastic ones and big ones like Tideway, and I just out of time couldn't put everything in. But just some personal points and things that I think are really interesting. So a long time ago, in fact, 34 years ago, I realized that cement wasn't concrete. I used to say, why are they spraying cement on the walls? And I was told, no, it's concrete. But for me, it wasn't actually concrete. When I look back, it was some kind of papier mâché that we used to spray on the wall through the dry spray process. We used to spray around 2 cubic meters an hour, and we used to start spraying a heading in the morning, and it'd probably be finished by the evening, and then you'd wade up to the face in gravel and your welly boots. So you can see my welly boots there. I was the thin, slim, athletic-looking one on the left. But we used to fill our boots up with gravel, not deliberately. They would just flow in. And baggings would burst, and I remember taking guys out of the tunnel with all the aggregates, peppering their skin, awful times, and the toxic atmosphere, and girders and mesh, and being lifted up to the roof in an excavator bucket was pretty normal, and those days this was all pretty understood and clear, but and I look back and I think, my goodness me, this wasn't that safe, and it wasn't very a good process. And we would rarely get above 18 MPa at 28 days shotcrete strengths. And my goodness me, we get there in about 10, 11 hours now, So things have really changed, and no exclusion zones or anything like that, But actually, we were building massive, probably the biggest structures at 40 meters below the seabed, with 21 meter spans and 15, 16 meters high and 180, 200 meters long. These were big structures, and God bless some of those people on that photo who've left us, but, award-winning stuff, and not to be ashamed of, but definitely the spray concrete was terrible, And then the Jubilee line, Heathrow Express, Channel Tunnel rail links, wet mix came, not dry mix, wet mix came, with low dust and low rebound, still temporary linings, permanent spray concrete secondary linings, and guys were still strapped on baskets on front of road headers and things like that. My goodness me, we'd have a field day in the current world. But actually, the robots came quite quickly, the robot spraying, and men were left to hold switches rather than nozzles in the end. Hindhead, permanent primary lining, spray membranes. My goodness me, how brave the highways were to have sprayed roofs as a finished surface. painted black, and to be honest, it looks good. But nothing new globally, but very new for the UK. But it was a really nice project. Lots of technologies sort of really established themselves that we see today. And that was quite some time ago now, if we think about it. I like 𝗦𝗽𝗲𝗿, got involved actually from both sides, from the equipment provision side, but also then in design. And I think what I really saw there was how we really removed all the lattice girders and meshes from the face. But this was obviously driven by previous work from Morgans and Colin Eddy and people like that, really creating a really safe environment. We didn't put men in the face anymore. And I think that was a really great change, and still not that well adopted globally, but in the UK very much adopted and very, very safe, but also very durable. And these linings, without all the steel, are good durably. But then we were using optical methods to control the profile rather than lattice girders. And then you can see that red line was pretty much on track. But the yellow line, the excavation line, not so good. And that's really a product of the soil that was 𝗦𝗽𝗿𝗃. But I would say is pretty much similar on a lot of projects where we tend to over excavate. We always need to over excavate to get the minimum thickness. But I think we're using 1.5 to 2 times the design amount of shotcrete every time. Now that can't be sustainable, and we need to get a grip of that, And then Crossrail, and this is where I got really back into design, and I think right from the beginning I really enjoyed the idea with the architects of creating these freeform designs, these curves, and we end up calling them Ross's belly curves. I don't know why, big fat curves like that. And these were the sketches that I originally remember doing, and how they got transformed then into architectural drawings and 3D walkthroughs and things like that, and eventually then into construction. I think there are a few contractors who want to kill me for putting these curves at the junctions, but I think they were really good. And of course, based on 𝗦𝗽𝗿𝗃 and the good success with spray membranes, we brought those to Crossrail and built secondary sprayed linings, clad them out, and that's where we are today. And I'm not open yet, but I'm really looking forward, and I think the public will really look forward to experiencing these Crossrail stations. I think you'd agree, they look great. Concrete, off-site, on-site, batching, and recently, of course, these dry silo systems, which are sort of like instant coffee in a big vessel that you add water and you get perfect sprayed concrete out of every time. I know it's not quite like that, but in principle, it's pretty good. And interestingly, this is creating interest globally as well on other urban areas, based on the success we've had in the UK, in London in particular. So moving quickly forward then, Northern Line profile controls again. I mean, I've shown these pictures internationally, and people cannot believe there's no profile in there, no physical profiles. They can't believe that we can achieve such geometry control without any physical forms, but we can, and we do. And bank station, again, I won't spend too long on this, but fantastic multidisciplinary project with multiple tunnels and complexity, like Victoria Station upgrade and others, all in London, creating these sort of intricate tunnels and they really shout out for these spray membranes. Unfortunately, not a Normet one, but equally a great job done with 𝗦𝗽𝗃 with their spray membrane. Fantastic. So where are we then? We pulled together and we've driven change in shotcrete tunnelling. I think we've done a good job where we've from even to Norwich was sprayed concrete, dry spray, but all through the Channel Tunnel, all through these projects, even through the hardships of collapses at Heathrow, you know, we've driven change and actually got so much better. Okay, the UK, I don't think people realise how well the UK is seen as an expert in sprayed concrete, both in design and construction, and that is exported globally on many projects. We are a centre of excellence, okay, in sprayed concrete. We have optimised permanent sprayed concrete linings. We've used a lot of spray membranes. I know they've got that Marmite effect. You know, people love them or hate them, but it is done, and we are doing more and more of these projects globally. And through the optical measurements, the optical total station, profile controls, extra mechanisation, and the use of structural fibres in the concrete, we've got rid of girders and meshes that needed to be installed in the face. And we've enhanced the durability of the linings as well. So we really got something really quite fantastic that we're doing. So this is all good stuff, really good stuff. But there's one box that we haven't ticked yet, right? And this is the decarbonisation of our shotcrete. And we need to, because it's quite a heavy carbon product, right? So our politicians, I'm not going to give any names because they might not be there. But if we're going to try and solve this carbon thing, what do we need to do? Okay. So we've got high levels of cement. We haven't got as many lattice girders and meshes as I had explained, but there are still a lot of that around. We always put more thickness on than we need to, because we've still got rebound, even though it's low, we still have it. We've got dust and rebound. We've got unused concrete. We've got multiple layers in our linings, and that actually adds thickness because of tolerances and complexity and risk, and all that equals carbon. Okay, so we've got to simplify what we're doing. And we've got a lot of diesel-powered construction equipment. I mean, it's good that actually most of the sprayers that we use are diesel and electric because they spray under electric. But generally, we've got a diesel equipment business going on here, right? Still. So we go across. We have a look at what Norway are up to. And this is an interesting project. It's actually under construction now. It's quite many kilometres of roadway, but there's about 30 kilometres of tunnelling. It's called the 𝗦𝗽𝗿𝗏 ferry-free road. And the ferry-free road, as it's called in Norway, is really to connect communities, right, and stop people having to use ferries, and creating this sustainable societal benefit of actually connecting people. So it's not about dropping the carbon down. It's really about community connections and helping people locally. So what you can see here is this typical approach in Norway where they actually do a rock support, very thin rock support, or based on the rock conditions with rock bolts, pre-grouting. But they also then do these sprayed canopies, and I'll show you that. This is a full sprayed canopy inside that rock support, and there's a gap actually between that and the rock reinforcement. So here you see it. This is the rock support behind, and all these bolts are actually to hold an internal canopy inside the tunnel. And this orangey white material is a PE foam. It's an insulating foam to actually stop groundwater that comes into the Norwegian tunnels from freezing and leaving ice on the road or freezing up things. So it's quite an amazing technique and very, very popular throughout Norway. And here you see another one. And on the side, you have these, actually for road tunnels, have these precast panels, a bit like the Hindhead approach, where you've got the high clean surface finishes on the sidewalls and then the sprayed roof around the top. And they just assemble these precast panels all the way down the tunnel and then spray the roof, normally with fibre reinforced shotcrete, as you can see here. to end up with these sort of high finishes on the sides of the road tunnels and spray concrete crowns over the top. In very densely populated areas or high traffic tunnels like in Oslo or in Bergen, they actually take those precast units right over the top. So there's actually no sprayed lining. So that's the sort of what I would call the traditional Norwegian tunneling. And you can see, again, another example, I think this was in Oslo, of these precast internal units. Now, they've had some developments. They're looking, like the UK, at sort of ways we can do things better. It's interestingly that most of the highway agencies, of which there are two, interestingly, are going back to have a look at cast in situ secondary linings with sheet membranes. Okay, so they're having a little dabble in that, and the rail authorities are having a little look at much thinner linings with permanent spray concrete and spray membranes. So it's quite an interesting division of technologies that's going on between the road authorities and the rail authorities, bar nor. And I know this is a sort of quite a complex slide, but what you see here are these traditional designs with these different canopies, and the blue bars are basically the rock support, the carbon in the rock support, and all the other multiple coloured lines above other than the secondary lining approaches. And the traditional designs, as you move towards just shotcrete, they get a bit with the precast liners, they lose a bit of carbon. So using precast sections tend to drop the carbon slightly. And then the new designs, the full concrete lining is quite a step in the wrong direction in carbon terms. And the spray concrete with membranes is a really significant drop in carbon, basically because of the amount of concrete used. So between the road, on the new designs, between the road and the rail, there's about a 60% difference in carbon. So that's something they're looking at, and there's a lot of work on these two areas. The reason that they're moving away from these PE foams is that there are a lot of fire risks with them. They've had some issues with the fire, and they have to coat them with a lot of concrete with PP fibers in to try and prevent the fire attacking them. It also masks the structural lining behind, so they can't do inspections. And also, basically, they're very expensive. So they are looking at these new ways. Most of these tunnels, though, in hard rock are pre-injected with microfine cement technologies and colloidal silicas and things like that, and are mostly pretty watertight anyway. And these sort of control measures are really to stop drips. So reducing carbon, I've looked at sort of, I think this is where Alan really opened my eyes to in his paper about breaking things down into equipment, materials design, and even operation maintenance. And I hope he doesn't go crazy, because I kind of summarized his points really, that equipment can save around 50% carbon, and materials and design combined can save around 20. Now, this paper was a couple of years ago, and we are looking at this through Norway, through what we're doing in Normet, and actually, it's not far off. Actually, if we do things, all the things that you'll see soon, we are around between 35 and 40% carbon reduction straight away. With things that we could do today. So we can do quite a lot. We can make big steps. On the equipment side, these are just ideas now. They're not set in stone. They're just thoughts that could be considered. We believe that training of people building tunnels is really important, and particularly spray concrete tunnels. So the simulator work that we're developing with 𝗦𝗲𝗿𝗲𝗿, with our own team, is really important. And these are a bit of fun pictures. That's in Tom McGowan winning at the BTS conference last year, and And we know he won because we can actually score people through many metrics in the simulator, and we can work out how good or bad they are. And he was the best of a terrible bunch of people that did this, but he should be proud of himself. And he got himself a bottle of champagne, which I had to lug around London quite a lot. But it's a really good tool. We can actually fast track appraisal and training of nozzle men now much quicker than perhaps the old routes and the old FNARC routes. And I think this is really important that we get people quite familiar with dexterity and the way they approach with these virtual reality headsets on. That it is pretty close to reality as it gets. So great tools. Then the electric drives, and I really firstly should thank the British tunneling industry for giving us this award for this kind of machine, this electric sprayer, and it's one of a kind. They are there. We are producing fully electric sprayers, and they replace the complete diesel units. I mean, they still spray under electric power, but they actually tram up and down the tunnels under a battery, which you can charge up, but it also charges once it's connected whilst it's spraying as well. So more often than not, you won't need to charge it at all. It'll just be fully powered. Zero emissions, no diesel fumes, carbon savings. Not bad. And where we're going with that technology is also in the future. We want to start to look to see if we can spray tunnels to profile more automatically rather than just thickness, to support the nozzle men in controlling the machines and controlling the spraying patterns and bring efficiencies. And possibly, who knows, in the future, with digitalization and good strong signals down the tunnel from Wi-Fi systems and things, we may even be able to spray without nozzle men. But let's see how that develops, right? And I think this is a really important point to bring up culture differences and behaviours in countries. And I like this distinction between Norway and UK. They're quite northern European countries. They're very similar in outlook and the ways they believe in their politics and everything. But there's quite a huge difference in the way technology is adopted. And I think the big thing to realise is that Norway has got 98% green energy. They are the green battery of Europe, right? So they've got free energy oozing out of every part of their country, and 90% of it is hydropower, right? Because they're blessed with those glaciated valleys and hanging water aquifers and lakes in the mountains, and then of course the fjords and by the sea. Huge incentives for people to go electric, and with their domestic car market, and 70% of all cars in Norway are electric. Can you believe that? Amazing. And they've stated that there will be no fossil fuel cars by 2025, in 3 years' time. Can you believe it? New incentives through government grants for the construction industry to go green, to go electric, right? 7 cities are designated as carbon neutral by 2025. So all their constructions will be carbon neutral. Right? Is that where we are in the UK? And the tunneling industry is adopting, as an example, our electric sprayers pretty readily. And it's probably the only country in the world that is doing it. In the UK, we're not that bad. 30% green energy is stated, but there is a day last year where we got to 58% green energy. So good, we can do it, right? And there is an increasing amount of wind and solar power coming on. We have minimal incentives for people. I think the best you can get with an electric car is get a free charger put in at home, and that's it, right? Having said that, 25% electric car market at the end of 2021, which was a doubling from 2020. And, you know, I can't see any adverts on TV for diesel vehicles anymore. No fossil fuel cars by 2030, okay. Government schemes, I'm being really optimistic here by saying government schemes gathering speed on reducing emissions. I think if we asked ourselves honestly, are we onto something here? But I don't see it too often in the projects we're involved in. A few tunnel projects in the UK are trialing some low carbon concrete mixes, but mostly for, you know, pile walls or for diaphragm walls or for things where gravity is okay, you know, nothing overhead. And no talk or very little talk of anything to do with electric equipment. So in Norway, just some examples. 𝗦𝗲𝗸𝗲𝗿, this is the railways, building tunnels with full electric systems, not just the sprayers. In Australia, we have one on the Connex projects in Australia, and they call it the Tesla, just for amusement, but you know. But I would like to say that the mining industry globally is far more onto this than the tunneling industry. And they are far more advanced in their approach to going to carbon neutral. And in fact, there's one mining company in Russia called 𝗦𝗲𝗿𝗲𝗿, who are going fully electric and producing their own sustainable energy near the mine to power the vehicle. So fantastic, completely green, 100% carbon, zero carbon. So a whole range of suite of equipment. I just thought it would be quite interesting to show you this. This is where we are today. We have a grid of fossil fuel energy coming to our sites. We put diesel in our vehicles. That's 100% carbon, right? We also are now trying to put electric vehicles on sites that are run off the grid with fossil fuels, like the UK, like India, like everywhere else. And it's a saving. It's probably about 20-30% saving on those electric, on the vehicles, on their carbon footprint. But if you're like Norway, where you've got 93% or more renewable, your grid is green, and you use green electric equipment, you are basically at the Paris Accord. You are 2050 ready, right? You are using green energy on green electric machines. So it's a choice that clients have. Do they want fossil fuel supplied energy, or do they want green energy to their projects, right? Where are they buying their power from? If they use electric equipment, they are 2050 approved. They're ready. They've done it. They're zero. So it's great. We're there today. Okay. Scanning technologies, really important, because I think we don't know what we're doing, right? Of course we know what we're doing, but I don't think we really know how well or how badly we're spraying concrete and how much we're using. And these tools, I would say a year ago, 2 years ago, I saw them as toys, right? Stuck on the front of the machines, recording things. Now I see them as vital, you know, in that we need to get working on scanning, 3D cloud scanning and digitalizing what we're doing, creating those digital twins that 𝗦𝗲𝗿𝗲𝗿 and Marco Invinici were talking about the last talk, right? This can be done on the machines now, and quite fast. We want to be able, the nozzle men, to make the decisions underground at the point of spraying, not to have the survey data taken out for the daily review meeting, go, oh, we've sprayed too little, oh, we've sprayed too much. You know, we need to be able to do it there and then. So the nozzleman goes, okay, I just need to put a bit more on, and it's done. Okay, so getting it right first time. And these scans, we're not real time yet. We can scan the profile in about 1 or 2 minutes and get an answer. So it's not brilliant, but you got a result in 2 minutes on the screen of the machine, underground, there and then, okay? As you can see in the bottom right. But what we'd like to do is take this further and start looking at profile control with the scanners, looking at better assessments of the materials used, creating a baseline of where we are, giving real-time feedback to the nozzleman rather than every 2 minutes. 3D coordinated data, so we need to georeference these things, geotechnical assessments, no more geologists in lifting baskets going up. We can get photogrammetry and overlay it with scans, right? And then we can feed all this back to BIM modeling and data twins. So this is where we're working. This is a serious part of our development at the moment. And we've created a new version. This is called Smart Scanner Line. It picks up on targets, georeference targets. The scanner opens up, scans the tunnel profile where you're about to spray, and you get the base scan, if you like. Then this is very fast in the animated world. We spray our tunnel linings. Okay, that's the whole lining sprayed, guys. And then we scan again. Okay, and then the nozzleman can see immediately where he needs to spray or whether he sprayed enough or whatever. And then he might spray a bit more and do a final scan. And all this information then, georeference, can go back into the model, right, into BIM model or into reporting, and it's an open language that can go into any other survey packages. So this is really important. It creates our baseline, our digitalization of where we are, and the view is that we should be able to reduce the amount of concrete we use, right? Be more efficient. That's what we're trying to get to. And there are other tools. I won't go into too much detail, but there are other tools like computer-controlled or aided spraying, so that the machine is taking over a bit of the working out, or that the nozzleman is trying to spray at the right angles, the right distances, in a more set pattern. And all these things further support carbon saving and efficiencies. Materials. Okay, I'll just take a quick drink. Everybody's focused on sprayed concrete with the amount of cement in it. Okay, and I think what I'm trying to get over is it's quite a few things that we need to look at, but cement certainly is a problem, right? CEM1, we love CEM1 in our tunneling world because it reacts with our accelerators, and it's really important that they do react, because we're spraying tons of material overhead, and they've got to be excuse me, gathering strength within a few, within 10, 15 minutes in order for us to work safely. So unlike putting low carbon concrete in the ground, spraying low carbon concrete overhead is another challenge, and we really need to be aware of the performance. But on that pie chart, that's a cubic meter of sprayed concrete. You can see that 77% of the carbon lies in cement, right? But there's also other big players like fibers and like some of the admixtures. But the big one, if we're going to do anything, it really is the cement that we need to focus on. And as I said, whatever we do, it has to enter that concrete stream continuously. If it doesn't enter continuously, it can cause real problems on the layering approach and safety of that material. It has to react with the cementitious binders, or react in other ways with other minerals. And it's got to be safe for the operative, right? We don't want more dust. We don't want any more toxicity that we had back in the Channel Tunnel days. And it's got to be safe for the structure. So we've got a lot of demands on getting this mixture right, and what we do. When we look at cements, there's a whole range of them, right? And the EN197, which is pretty an international kind of view, is the CEM1s, the CEM2s and 3s. And they all contain Portland cement, and it's about 100% Portland cement at the top, which is CEM1. And as you go down that list, the amount of Portland cement in these blends reduces. And generally speaking, as you go down with less Portland cement, of course, it becomes a greener cement, or eco cements, as they can be called. Okay. But what it means for us in the sprayed concrete world is, generally speaking, and I mean generally speaking, those cements are less performing when it comes to early age strength. They can be higher performing in long-term situations in terms of durability, pozzolanic behaviors and the like, but it's those first 5, 10, 15, 20-hour strengths that we really need in spray concrete for safety and for building thick linings. In Normet, we've had quite a lot of good experience, of course, with CEM1, but even in the CEM2s, which are these sort of blends, we've got quite a good experience. Actually, they can work. In fact, a lot of countries now are having more blends than pure CEM1. To get CEM1 in some countries, it's just impossible. So we've been forced to look at these sort of blended cements. And one interesting project that was a Hinkley project where we had these robots and these mixes for a massive earth retaining structure for the reactors, 35-meter high walls, you know, really interesting project. And we were asked to look at 3 mixes at the beginning. And one of them was based on GGBS without microsilica and all those other things. And we did a lot of lab work and we did a lot of trials, and it was perfectly great. But they didn't choose that in the end. They just went with the normal standard microsilica pure Portland cement mix. And if we'd been where we are today, I think that the decision would have been very different. But actually, I'm just showing you there, you know, today we can cut carbon. This is, and by the way, this is the first time I'd ever calculated the amount of carbon in the concrete mix before. I didn't, until a few months ago, I didn't have a clue. If someone said, how many kgs of carbon do you have in a concrete mix? I wouldn't have had a clue. But I know now it's 550, 570 kgs of carbon, right? And I know that if I put 25% GGBS in, I can cut that by 40, 50% down to 300, right? So today, without any technology changes, we can cut carbon in our concrete by 40, 50% for tunneling today. The next step would be to go even further and to go to really, really what I would call ultra low carbon concretes or spray concretes. That's going to take work. And I know people have been trying with powders and things like that, which are causing some issues for me in terms of mixing, in terms of toxicity, in terms of alkalis and other things. But I think the thinking needs to change. We can actually get the chemistry right and we can make that work. There have been trials we've done without any cement in, without any Portland cement, geopolymer spray concretes we've looked at. I know Charles Allen is itching to help me look at this, and because I have an issue, we've made this really work to some extent. This is cement-free spray concrete. We sprayed it, and we get superb early strengths with it. We can get 5 MPa in 3 hours, which is great. You know, this is super safe for the tunnelers, but we sort of stops after 6 or 7 days and goes flat and stays at 15 MPa roughly. But I think there are ways that we can push up that strength, you know, up to 20, 30 MPa. And according to my designer friends, you know, that's no problem as long as they know what they've got. They can design linings on it. But it's interesting, you know, we could really drop the cement down to 0, you know, if that's what we need to do. So moving on very quickly, we've got this durable spray concrete. We've got performing equipment and materials. We've got well-trained people now with the simulators and the support there. And we've got quite a good knowledge on design with permanent spray concretes, with spray membranes, detailing. We've got a lot of calibrated models now, particularly for London. You know, where do we go with design? And of course, these spray membranes could be quite integral to that. I mean, Betty Consulting is an example from India. They just done these big crossover caverns on the Mumbai metro, and we've taken out all the reinforcement and all the concrete from the secondary lining, and produce a thinner or more efficient sprayed concrete lining with the membranes. So huge time savings, huge carbon savings, and cost savings. So it's really turned out really well. It's just about finished. These are the membranes going on and the secondary sprayed linings. And this is pretty typical. We've seen that in Singapore, and this is going on almost daily now in Australia. So just to give you a flavour, that this is not just something that we did on Crossrail and Hindhead, but it is actually globally happening, and even in Norway as well now. So we looked, interestingly, we did a quick exercise with 𝗦𝗲𝗿𝗍 Consulting. Actually, we went back to Crossrail and looked at the platform tunnels again with some different lining configurations and different materials. And what we looked at the original design, as you see on the left, down the bottom left, and in the middle, an optimized design where we took out regulating layers and just put a membrane. So we're looking at a new kind of membrane that we could use there and take out the complexity of all these different layers, try and make it three. And then where we'd like to go is a much simpler spray concrete tunnel lining of one big structural waterproof lining with a waterproof catch-all, umbrella, membrane, mortar, whatever you like to call it, on the inside. A bit like a segmental lining, if you like. So joints, construction joints between each bays, but then having a full coating, a full continuous coating on the inside, flexible and waterproof, and maybe aesthetically pleasing for certain tunnels as well. So we're trying to simplify and sort things out in a way. So we looked at we used the same model, the same finite element model. We looked at these three different linings, and then of course came out with moment interaction diagrams on those three options, and they all actually satisfy the design, even though they're much thinner than what the original Crossrail design was. And there were constraints in Crossrail where the water was acting, but I think under new ways of thinking about the lining design, I think we could make quite considerable savings compared to where we were 10 years ago with Crossrail. So these are sort of the crazy stuff that we're thinking about. This is that material that Ryan is holding there is actually concrete. It's not breaking. It's actually flexible. So there are some weird, wonderful things we can do with mortars and cement-based systems with certain polymer technologies. I don't think we need it to be this flexible. This was one of the prototypes. We don't want wobbly, bendy tunnels too much, but certainly it's just to emphasize that you can get certain flexibilities with sprayed materials or cast materials like this. So on those options that we looked at with 𝗦𝗍𝗍𝗍 Consulting, our initial studies looked at a sort of optimized design. We could get around 30% carbon saving with that. With this sort of much simplified approach, we're almost halving the lining thickness and getting around about 43% saving in carbon. And that's without even changing the cement type. So if we were, excuse me, if we were to change the cement as well, we could be over 50–60%. They're wild ideas. They're wild ideas, but that's what we're working on, and hopefully we can get that to work. So that coating and those sort of new membranes are going through a process of approval internally. We set the performance criteria, we do the lab tests, we do spraying trials, and hopefully we find a nice client who will like to try it in a big tunnel somewhere, right? And that's what I'm missing a little bit in our industry. From the days we were doing trials at Heathrow, at Jubilee Line and other places, we don't do that anymore at the moment. And I think it's time to really look at full-scale trials with new technologies again. So these are sort of scale-up trials we do. I mean, this is in Derbyshire with Cemex, who supply, we partner with on the dry silo mortar systems. So we're producing wet mix and spraying panels. That is a normal guy, he's just on his knees, but it shows the kind of dedication we need in the industry to get on your knees and I don't think he's praying. I think he's just looking to make sure the panels are sprayed really well. And so it's high flow concrete, it's permanent spray concrete with fibres. We then actually put water through those panels with pressure to simulate what you guys realised is always the nightmare for spray membranes with water ingress coming in. We then spray the panels, and this is a new version. It's fast setting. You can actually spray over this in an hour. So it's immediately curing as well. So it's quite a novel system. There is one little bit of high pressure water coming, but all the membrane around there is fully cured. Unlike today, where they don't cure at all if you've got water ingress, and it can wash out all the polymers. But this is immediately curing, and this is very easily sealed then with injection. So really nice step up from where we are. We hope this will be quite an interesting thing for the future. And of course, we do all the sampling and testing and bonding and looking at the integrity of the membrane. And this was the idea of coating just a simply sprayed concrete lining with a membrane that actually covers everything, covers the fibers and all the irregularities of the substrate. And this potentially could be viable. I mean, it's a really low cost tunnel lining solution, very low carbon. You're basically halving the lining thickness compared to Crossrail. Could be something for non-public tunnels to start with and see where we go. But we need to trial it on a big scale. So what's next? Well, we got all these wonderful ideas, and I think I go back to 𝗦𝗽𝗲𝗿 from 𝗦𝗽𝗲𝗿𝗲, and I think we need to look at carbon management, and I'm not going to spend too long on this, but basically, the sooner you get involved in carbon in a project, like in the planning stage or in the design stage, the better. Trying to make carbon savings during construction is really about just driving efficiencies. So it's in the design sections where the big savings can be made. And this carbon management in infrastructure, the BTS 2080, basically says, first assess if you actually need to build a tunnel, right? Are you seriously wanting to build a tunnel? And we all go, yes, of course you are. But actually, sometimes it doesn't need to be, right? And then they might say, well, actually, can we upgrade existing structures? So let's build less. And there's a lot of work we can do to support in the industry existing tunnels and making them suitable for upgrade or for maintaining or extending their life. So those are quite good carbon approaches. And then, of course, if we're going to build new, build clever, do a good design, look at the ways we can bring in low carbon technologies. And then when we come to construction, build efficiently, do everything you can, monitor it, see where your carbon, do a carbon inventory and use less concrete. So very quickly, I mean, we're looking at this now, and I think that's how the industry should see it, is it's not just about low carbon concrete, it's actually also about looking at design, looking at construction, and I haven't calculated all the numbers, and this is a kind of representation, but that's what we need to do. We need to start putting numbers on what we can do to lower carbon. I think we'd be pleasantly surprised at what we can do. Okay. But carbon, I think this is a tricky topic because the Treasury for all public projects have what they call the Green Book, right? And it's just been redone in 2020. And this sort of gives prospective projects a way of evaluating them in terms of costs and everything, but also in carbon. And the Department of Business, Energy and Industry Strategy have established values for carbon, and they did so in 2018, prior to COVID and all those sorts of things. And the price of carbon I didn't even bat an eyelid. If someone said the price of carbon was £40 a ton, I would go, okay. But now they're telling me it's £250 a ton, right? So you can see where the government are going with giving high values to carbon, right, in infrastructure projects, it does mean something for us, right? This isn't just a book for fun. I mean, this means that we need to take carbon very seriously. It is 9 times the value it was 3 years ago. Okay, so we've got to wake up and think what we're going to do about this. I'd like to be more positive and say that sprayed concrete tunneling brings broader sustainability benefits, and through projects that really promote sustainability in the broader sense of the word. And I just will finish off the talk tonight on just some of these highlights. I'm really, I think most of us are really pleased, not for the fact it's more work, but the fact that the UK have after 40 years, have started the hydro schemes again. And of course, there's been a few little ones, but the 𝗦𝗽𝗲𝗿𝗲 project is quite a project. And it's really great to see that that's go ahead. It's a pumped hydro scheme that allows us to actually put all this renewable energy into storage and use it when we need it. And I've again come back to Norway. Norway are pretty hot on hydro. They're not the biggest in the world, but there are other countries that outperform them. But I think you can just see that the Norwegians have quite a hydropower business, and the UK has quite a hydropower business, but nothing like Norway. And 80% of our power comes from 7 plants, and actually most of that, Kate, it comes from Wales at the moment, because everybody says it's in Scotland, but actually it's in Wales. But 𝗦𝗽𝗲𝗿𝗲 will change that, and there'll be a balance between Wales and Scotland in terms of pump storage, and probably they're the biggest 2 providers. Interestingly, though, National Grid last year said we need 10 gigawatts of storage by 2030, and we need 40 gigawatts by 2050, really because of the growth in electrification of our life, right? Because of electric cars, because of electric heating at home, and no reliance on gas. And of course, there's nuclear coming into that, of course. And industry will need electricity, so that we, as a population, we're going to use more and more electricity. So we need these storages, and we will develop more wind power and solar power, and we need to then harness that and store it. And pump storage schemes actually are really cool because they can store huge amounts of energy and deliver it at the press of a button. So they're very, very big batteries, right? And underground, and building these things is done with spray concrete, right? And all the things that we're good at. So we're currently at 4 gigawatts in the UK, and 𝗦𝗽𝗲𝗿𝗲 will add 1.5. So by the time that's built, we'll still want to be at 10 gigawatts. So I think we've got quite a good business ahead of us in terms of building pump storage schemes. And in Norway, they are pretty good, and they're not always pump storage. These are just pure hydro schemes, which are very fortunate to have from their topography. This is the 𝗦𝗽𝗲𝗏 scheme being built by 𝗦𝗽𝗲𝗏, and Normet we got all our spray machines in there doing sprayed concrete. And of course, the other one then is 𝗦𝗲𝗏𝗏𝗏, and this is like a drop of 600, 700 meters from a lake at the top, and producing huge amounts of power. And all of these projects involve pre-injection of the rock mass and single shell spray concrete lining. So, I think that's something the UK could consider, in our new economy of green energy. And this is one of the powerhouses underground. And I said, well, send me a picture of the real thing, and they said, this is the real thing. I said, that cannot be a real turbine hall. Yes, it is. I said, no, it's a graphic. No, it's the real thing. Can you believe it? I mean, it's fantastic. And talking more fantasy, I'd like to talk about very quickly sustainable projects like community and social benefits of actually looking after communities isolated communities, particularly in islands. And we have them. We've got the Hebrides, the Skye, and all the sort of Scottish islands, a bit like the sort of Norwegian or the Faroe Islands. But these guys in the Faroe Islands are just incredible. I mean, there's Norwegian tunnellers and contractors and designers there. And the benefits really have been putting tunnels between the islands is supporting communities and stopping the migration of these people away from the islands to mainlands, right? And allowing them to live in these communities. It's also about safety, because actually the ferries and the aircraft in and out of the islands can't fly in bad weather, can't sail in bad weather. So you need fixed links if you want to have safe communications. And actually, there's economies, and the balance sheet works on the long term against the ferries with the tunnel approach, and they're actually very profitable, because they actually run them as toll schemes and take money through tolls. So they are financing. And interestingly, these are Faroe Islanders. They've got 40. Can you believe they've got 44 kilometres of existing tunnels built since the late 60s? They got 2 more massive tunnels being completed next year. They got 30 kilometres more in planning, and it's 50,000 inhabitants. I mean, goodness me. Don't tell the people in the Shetland Islands, of which there are 22,000 of them. I mean, they'll want half of this in tunnelling as well. So, I know that I think Andy Sloan from Covey was discussing this with me before, and I think there's interest really to look at these connecting tunnels, and they can be very low cost sprayed concrete structures that actually can, as long as you put your windscreen wipers on, you're okay, if there's a few drips here and there. But actually you can produce quite efficient tunnels, and these guys have proven it, both in Norway and in the Faroe Islands. So quite an interesting role for sprayed concrete tunneling. So I'm coming to the end. This is the last but one slide, and it's really about, getting things moving. What are we doing? We've got a lot of talk in the press and the media and the UN and politicians and COP26, and I'm not hearing too much really from the industry yet on this. I know there's been a few trials on sprayed concrete and a few other bits of concrete being done, but I think we really need to start thinking more seriously about what we're doing about carbon reduction. And we need to incentivize the contractors, right? And they used to innovate, but I think it's other companies further in, a little lower in the supply chain now, who are doing this kind of innovation. But I think the whole chain needs to be committed. We need to really start thinking about carbon seriously. We need to, I think we're as you can see from the slides, we've got lots of ideas, lots of thoughts of how we can do it. We're up for the challenge, right? But we don't feel the pull, if to put it in those terms. So how do we kick it off? We think that client leadership is really key, because at the end of the day, they have an inherent interest and they've got an ownership of this asset for its operational life. So I think, given those sort of carbon costs and the responsibility we have to do something in our industry to reduce carbon and to reduce climate warming or global warming and to go towards net zero by 2050, we need to do something. And we think that client leadership is quite key here, not government, but clients. And I think one of the other thoughts is that carbon must become a differentiator in project procurement, right? Because it isn't at the moment too much. And maybe there are, I know TfL have got some percentages for carbon approaches, lower carbon approaches, but I don't see that too much in the tunneling industry. So perhaps, crazily, should we be pricing carbon rather than concrete and steel? Could we put carbon reduction project or targets against the kind of carbon baseline? And how do we reward innovation? How do we get that moving? And And I like this imagery for those British people who understand these sort of words and sayings like carrots and sticks. Do you give people carrots to push them along, or do you beat them with a stick to push them along? And I mean, carrots for me are things like reward and incentivization and allowing people to express what they could do and present ideas to big projects and then win because they're bringing low carbon ideas. And sticks generally I think of as legislation, tax, rigid specification and that kind of stuff, which don't foster innovation and new ideas. So, and I think in Norway, it's very much a carrot approach. And for example, the government are actually incentivizing contractors with which are seemingly high costs, upfront costs on equipment, let's say, and rebating them that difference between the traditional diesel equipment and also on the materials. So that sort of difference in between the low carbon cost and the standard material or equipment or whatever, they're actually giving them 40%, 50% rebates on that. So, I think that's what we really need to think about is, do we beat people into low carbon tunneling, or do we pull them in and encourage them and reward them through project awards with good carbon and safe solutions? So very quickly, the new BTS specification, I really like the way that's going. I think, 𝗦𝗲𝗍𝗲, for the bits that I've been involved in on sprayed concrete, we've opened it up. I think we're really making a good way forwards with that. Thumbs up. Seriously, the British Tunneling Society, the British tunneling industry is a global leader. We are listened to and taken seriously. And I think we need, hopefully, we need to lead that in sustainable tunneling, whether it's sprayed concrete or TBMs, but certainly sprayed concrete would be my vote. We need to start measuring carbon baseline. We have no clue where we are. We have no clue where we are. We need to start measuring and getting a baseline down. How much carbon are we using? Implement it should be 2080 carbon management for infrastructure projects. Re-energize the spirit we had post-collapse at Heathrow. And we've got great people in our industry. We need to bring them together and get this thing moving. Develop project reward models, I mentioned that. Let's not rely on legislation and taxing to push us into it. And if we do, and if we are forced into that, let's ensure that we have a win-win solution and the innovation is encouraged. And we need to know that there are upfront costs with going to a low carbon solution. There are. But we need to balance that with the long-term operational environmental benefits. And I think the client team-led approach, they understand that, and that's what they need to deliver. And finally, consider sustainability in the sprayed concrete world in a broader sense. And I think, SCL, sprayed concrete linings, or sprayed concrete tunneling has a role to play in bringing some quite interesting projects. And I think as we move out of London and go north into the rock country and doing all these sort of hydro schemes and underground gas storage, underground pump storage schemes, you will see SCL in a new way. I mean, it's been all about infrastructure projects in London, and I think we will see a different kind of sprayed concrete business. We have a few more Corrie glasses to build, I believe, if we're going to get on our road to net zero. So that's it. I hope it was quite, I have not all the answers. I hope it was quite sort of an inspiring kind of talk in terms of carbon. I'm not sure how much of you get involved. I'm sure some of you are way more expert than I, but I'm really interested in helping client teams, contractor teams, designer teams in looking at ways we can do this better. And I mean that from a BTS point of view, not from a Normet point of view, but from a BTS from a bigger point of view. You know, I think the UK industry, tunneling industry, is a great organisation. You know, we need to get back on top of this topic. Thank you, Kate, and everybody.
Well, thank you, Ross. I think that has been an enormously inspiring, I think, call to arms. And I've been given the encouraging note to note that you've actually got lots of questions. So I hope in likes with myself, you've really inspired and given us a great start to 2022. I think there's been a number of thought-provoking things there. So I've been advised that there are many questions. We'll do our best to cover some good ones. But yeah, I think a really great start to the year. So where should we go first? Right. So the first one is in from Lucy Rue. How is the thickness of the shotcrete controlled without a physical profile?
Well, to date, it's been done by, quite an interesting communication approach between a surveyor or an engineer on the side of the tunnel with a total station and the nozzle man or an excavator driver excavating or spraying. And this engineer can actually put the laser of the total station around the profile and bark orders at the excavator driver or nozzle person to make the adjustments he needs to. So it's very based on communication skills and technical skills on a total station. But you know what? It works. It is quite incredible. So I think from our point of view, from a spraying technology point of view, moving forwards, we'd like to maybe automate that and to be able to give real-time feedback to the nozzle man using 3D cloud scanning as to how he's going and how things are developing. And the same technology could be used for excavation as well. So it's basically total station measurement basically at the moment. Dynamic.
So next up we've got Lang. What are the challenges of spraying concrete lining on wet rock surface and how do we overcome it?
Sorry, could you repeat that again? I can't see.
Yeah, so it was, what are the challenges of sprayed concrete lining on wet rock surface and how do we overcome it?
Well, the word wet is we have to be a bit more quantitative than that. And of course, damp is fine, wet is fine. Little springs are fine. Then if we start getting huge water ingresses, not fine, not safe, not good for anybody. So we need to sort of be able to predict the water ingress into the tunnels and then decide on the approach. So if we go to Norway in going through a mountain for a hydro scheme or a subsea tunnel, right? They will systematically pre-inject the hard rock with micro cement, right, as a matter of course, and that controls these massive water ingresses. Okay, in London we've got basically London clay, and that's pretty impermeable, and we get some seepages after a few months. Now in London we also have the chalk, right? So underneath the Thames or on these places we get sometimes these massive deluges of water. So and it's quite interesting with designers. They have like these toolbox measures like dewatering. So, but it can be quite serious if we get these massive watering rushes. So, pre-grouting ahead of the face is pretty important. If you've got medium or moderate water ingress, you can normally channel that during spraying or actually put some dewatering holes ahead of you. And if it's less than that, you can normally just put strip drains and use slightly higher or performing accelerators so that the concrete is more resilient against the water. But it's very hard to stop big rushes of water with spray concrete. You have to control it.
Okay. Next up, we've got one from Natalie. Why do you think there is a division between technologies with railway and highway organisations?
Yeah, a good one. I think the railways don't mind the finish of the tunnel. So one of the big drivers, and I always remember learning with Keith Bowers and TRL about the value of surface finish. Nothing to do with structural linings, but just a pure surface finish for road tunnels has to be optimum. I mean, if you go into a UK road tunnel, you basically can get sunburn from the amount of lights that they've got in there. In some places of the world, you won't see any lights at all. You have to switch your headlights on. But most sort of highly dense projects or highly traffic projects, road projects, require that high reflectance on the side and cleaning, and there's a lot of dust and debris. So that doesn't really bode well for sprayed concrete linings in road tunnels, even though at Hindhead we've got it over the roof, and in Norway we've got them over the roof, so it kind of works. In rail tunnels, we don't have that problem, of reflectance or finish. It's a dark tunnel and people in their safe carriages being whizzed along at high speed. So finish is not that important, and I think that's why they can get away with it.
Okay. Next up, we've got a question from Yanis. Design optimization can result in lower SEL thicknesses, but is it that critical? Is material technology more important in the end to achieve decarbonisation?
Yeah, I think both. Yes, a good point. I think material. We can decarbonise with the same thicknesses. We can decarbonise by thinning the linings. But imagine if we did both. Is double benefit. So I agree. I think we have to. What would be nice to do would be to do it all in one big step. And that's why I call my presentation Little Steps, because I think we just need to take those small steps and maybe material change first and then design lining optimization later. But it's certainly, if you can do it and if you can demonstrate it, both might be possible. I think it is possible. They are both possible. But yeah, you don't have to do both. You can do one. At least it's a change in a good direction, whichever way you go.
So the next one, we've got one from Lang. Do you think clients should start specifying requirements of green technologies in order to promote fair and competitive pricing among tenderers?
Yeah. I think it could be, you could do it in two ways, I suppose. You could do it like in a kind of performance criteria approach about amount of carbon per length of tunnel, or you could be more specific about technologies. I think to drive the innovation, I would be going in a sort of performance approach, But I think we need to start pricing carbon and evaluating carbon in the procurement some way. But there's some smart cookies out there, Kate, that I think could probably help there.
I would agree. So the next one then is from Claudio. What are the key aspects to specify a low carbon shotcrete without compromising safety and durability?
That's a good question, and that's what we're faced with in the industry now. I think we need to ensure that we have homogeneous mixing, that we have minimum requirements stated by the designer in terms of material performance, because I think that would allow us then to be creative in how we achieve it. But there are concerns about durability aspects of some very, very low carbon approaches at the moment, both in concrete and in sprayed concrete. So we really need to understand those. But certainly, from where we are, like I mentioned with GGBS replacement, which again we need to question how sustainable that will be in the long run. But we do have very much a way of specifying concrete now for low carbon. We were doing it with sort of environmental exposure classes, but we could perhaps do it with carbon contents. Maximizing the carbon content of the sprayed concrete mix, for example. maybe, and then that gives the freedom to do it in whichever way you can.
Okay. The next one we've got in is from John. What accelerators have Normet available for ultra low carbon concretes?
I would say none yet.
Okay. But watch this space is what I'm seeing. The next one in is from Yanis again. How could we demonstrate that such an approach adopting a thin lining could be applied and provide safety upon completion of the lining and reduce people's reluctance?
Well, as I mentioned in the presentation, I think the development of solutions comes from the lab through scale-up trials through to full-scale trials, and there is nothing better than doing. I mean, of course, you can model the hell out of things with finite element analyses, finite element modeling, but nothing beats actually building these things in real. And I think when we've looked at the sort of technologies that we've developed in the industry over the last 34 years, there's been a series of trials at certain points, serious trials, which have been fully monitored and fully evaluated, both from materials and structurally. And I think that's where we need to go. We just need a client that's willing to look at it, or a group of clients that want to invest and look at it. But that's what we need. We need to do trials.
Okay, the next question then is CEM3 with appropriate accelerators sprayed concrete versus geopolymer with high carbon activator sprayed concrete. Which is the more likely route to low carbon? And this is from Chris.
Whew. I think I'd like to do this presentation again next January. This is a race now in the industry to get this sorted. I think the geopolymer is interesting because my concern with sort of cement replacements like GGBS, PFAs is that we don't produce much steel in the UK. We don't burn much coal in the UK. I know that we can get sources from outside the UK and within the UK a limited amount of GGBS. But I think, when we refer to sustainability, I'm concerned whether they are sustainable, right? In terms of, because everybody will want it now for this low carbon approach. So I think the geopolymer is interesting because it opens up a way to use quite a lot of different fillers and materials without being sort of stuck into these sort of burnt materials that we get from other industry processes. So there's lots of ideas, even sort of all the ash that we produce from incinerators, bottom ash it's called, maybe there's ways we can process that and use those kind of materials. So burning ashes, burning refuse and waste for energy generation produces quite an interesting byproduct that we may be able to use as well. So it's not limited to. So I think the geopolymer could be quite interesting as a route, but we're early days yet at the moment.
Okay.
But we're on it.
So the next one, we've got one from Lucy. What is the key to reducing rebound?
Oh, that's an interesting one. Well, on the channel tunnel, I said 30%. It could have even been more. I did a survey actually in Norway on our intranet. I said, how much percentage rebound do you think your projects have got? And it ranged from 20% down to 3%. We did a trial actually at a line JV for the cross passages, and I think Steve Parker. I'm not sure if it's the Steve Parker or another Steve Parker, but we did some rebound measurements from trials. They were at 3-4%. So typically it's around 8-9% on tunneling, and I think the rebound issue has been exacerbated by this hunt for really super early strengths under the J2, for soft ground tunnelling. So we tend to then load the shotcrete with very high levels of accelerated dosages, sort of 7-8%. And that inevitably causes more rebound. And so the accelerated development, that we're looking at is to basically have what we call a soft start accelerator. So it would actually be more receptive when you spray it to all the aggregates and fibers and everything going in and staying there, then going and freezing, right? So so reducing rebound is accelerated technology, training, simulator training, and getting operatives better aware of what they're doing with the machines, the air settings, the accelerator settings, the concrete outputs, the nozzle behaviors, computer automated spraying or computer assisted spraying. All of these things, contribute to lower rebound. But I think there's some interesting technologies coming that could actually support much lower rebounds. Yeah. So I think it's coming. I think it's pretty good, but it's still 8% of the material is still on the floor. Maybe that's not the target we need to hit first. Maybe it's the amount of concrete we're spraying. The 1.5 to 2 times the design thickness that we have in soft ground tunneling, and up to 3 times the design thickness in rock tunneling. Can you believe it?
Yeah. So the next question then is in from Dave Hindle. In my view, by any measure, tunnels in terms of their whole life use are the most sustainable form of construction ever devised, no matter how they are built. Do you agree?
Yes. I always agree with David. Absolutely right. And we can see that. I mean, you just look at the examples of Norway, Faroe Islands. Look at the structures that the benefits and that we're getting from massive infrastructure projects like Dimmock. Almost 50% of the pump storage capacity in the UK. So we need to embrace this sort of underground tunneling technologies. And I think spray concrete fits the bill for a lot of the complex stuff. I mean, long TBM drives for rail and for service tunnels, fine, great. But sort of hydro schemes, big underground stations, I think it's still valid. But yeah, best long-term benefits.
Okay, the next one then is in from Chris. How do we adapt industry standard prescriptive specs to a performance culture that encourages innovation?
Okay.
Yeah.
I
think should we get you back next year for that question?
It's interesting. I mean, I'm a great supporter of performance-based specs, and it's quite funny because when we've been writing specs for spray concrete over the last few years, I remember I was a culprit of my own knowledge on Crossrail when we were developing that, was that there's so much specification out there through the EN standards that you can actually just refer to them when you're writing a spray concrete spec and expect people then to go and search out the EN standards and work out all the clauses that are relevant. So it's sort of finding a balance between rewriting everything and being very specific and to guide your contractors in the right way to what you want, or to give them the freedom based on EN standards and give them trust and hope that they actually work it out. So it's I think what you see in a lot of the specs, whether it be HS2 or Crossrail or Jubilee Line, there are a lot of people are rewriting basically things that are already there. So I hope the BTS spec now with 𝗦𝗲𝗿 can give a really nice new fresh framework for contracts to work on, and it's a real opportunity for us to get that right, as a framework for other UK tunnel projects. Okay. But performance based is the best always. because it gives innovation, it gives freedom to innovate then.
I think that draws us to a close on questions from YouTube, but I have one question for you myself. Looking at the savings you identify and could have been made on a Crossrail and a project of such size, how many have you've talked about doing more calculations in the future around this? Have you had a thought on thinking about how many hydro schemes we could have built with the savings for to be carbon neutral of balanced? And maybe should we be talking about, because obviously with the size of a project as such a Crossrail, should we be talking about what other things we could build that obviously have a double benefit of being able to achieve the sustainable energy solutions as well?
Yeah, I think the British Tunneling Society has a role to play here, you know, and advising government even, and bringing the right individuals, Kate, you know, from the industry together. And I think the UK government and even the devolved governments would be very interested. I mean, I was shocked, for example, that Wales, for example, was the biggest pump storage schemes in. I thought everything was in Scotland. You know, it's very little in England. Strangely, you know, when you think of the topography, there must be real opportunities in England for schemes as well. But it seems to be basically Scotland and Wales, and I was surprised that Wales has the biggest storage capacity. So, you know, I think the Coire Glas is a great step forward, and I think of all those reservoirs and things that could actually be turned into hydro schemes as well. You know, so you know, I think we had a bit of a chat with London Bridge Associates about that with Dave Sharrocks and Coes, and I think there's real opportunity for this green batteries and storage, hydrogen storage, and other things. You know. That we could be looking at, not just infrastructure, you know, moving people, you know.
Well, I think from me, on behalf of the BTS and everyone that's with us here tonight and watching in the future, I just want to say a big thank you. It's been a really inspiring start to 2022. And I think taking and reflecting on sort of a period through COVID has maybe sort of, I think, has helped people to additionally look at some of this challenge. Obviously, seeing your pictures right at the beginning, a lot of people look at the negatives from COVID, but actually it did challenge us on what we are doing to our planet and helped, I think, to get people thinking in a different way. And I think it was very interesting to look back at what advances we've had in the techniques and the technologies that we use to build our assets and in terms of contribute to society. And I think you're quite right that we've got the right minds in this industry to solve this. I think you've certainly laid down a challenge to us all here today, to think big, but also to challenge ourselves and probably understand the language that we're using and how we're measuring it and costing. I'm sure many that are here tonight are thinking of lots of different projects in terms of how we can change some of this, but how we can make it quite accessible for people to be thinking about what that amount of carbon really means. It's quite frightening what you said. Everyone knows how big a Crossrail project is, and when we can all travel on it, I think we can all appreciate that's a lot of concrete that could have been saved.
Yeah.
But I also was encouraged by the fact that there's a number of quick wins, and actually those are where we should be looking first. But we do need to be encouraging how we look at the bigger picture. There are so many things we could do. And I think probably possibly for some it's knowing where to start. So I think you've laid down a number of really viable solutions and starting points for people today. And I think it would be great to have you back in the future as well. We've got to keep this conversation going. As the slide says in front of you, we're celebrating 50 years of the British Tunnelling Society. So who knows where we will be in the next 50 years? If we think of the developments that we could have just in this year alone, the future is bright. But I think we've got lots of great minds to call to this mission. So thank you very much for giving us your time tonight. Thank you.
My pleasure. Thank you, Kate.
Okay, I think we've got a couple of slides this evening. So the first one is, obviously, as we're back online this evening, we do have a post-lecture social, so please feel free to join us on Zoom if you follow the bit.ly link that will take you to the BTS bar. Next slide. We're just getting the slides to update. Yep. So we have a Zoom BTS bar tonight. Unfortunately, obviously, we're back online this evening. So look forward to many of you joining us. If you follow the bit.ly link, that will take you to the Zoom dial-in, and you'll be able to join a breakout room. Next slide. Okay, just as a reminder, BTS memberships are due for renewal this month. And if you're not yet a member, please consider being a member and supporting the work of the BTS. Individual memberships start at £85, young members at £42. And there are discounts available for retired members, students, and apprentices. And corporate memberships start at £430. So please visit the BTS website for further information. And through becoming a member of the BTS, there's a number of different things that you can get involved with, and also to take up kind of some of the missions and things that Ross has put to us this evening. Next slide. So the next event we have is a joint event with Min South, and they'll be hosting that for us on Thursday, the 10th of February. And this is a slightly later start. This starts at 7 o'clock online. So please look out for details of that one. The next BTS evening meeting is in March, and that's Thursday, 17th of March. And it's on the design and construction of a cavern in downtown Los Angeles. And that, fingers crossed, after all the announcements last night, will be in person at the ICE with back to a 6 o'clock start. And then on Thursday, the 21st of April, we have the Harding Prize presentations from the Harding Prize finalists. And that again will be in person starting at 6 o'clock. So just a reminder, if you have any paper or lecture topics on a subject of interest to the industry, please get in touch with us. We're always interested in all your ideas so we can bring a variety of topics to the BTS each year. So please contact Sarah Langley, or if you have one particularly that you want to target to share with the BTSYM, please also copy to btsym@britishtunneling.com. So the next one then, I mentioned that the Harding Prize is not that far away. So we've got a call for papers out. So we are taking papers up to the 11th of February for original papers on any subject relating to tunnelling. And it's open to any individual aged 33 or under. We had a fantastic number of entrants last year, and we're looking for the same this year. So please get your papers ready. Hopefully, maybe Ross has also inspired a few extras this evening. And if you send that to bts@britishtunneling.com. Next slide. The next one is a reminder about the Doug Allenby Memorial Award, Memorial Medal even, apologies. We've got a call for applications here if you apply by the 6th of February. And further information is available on the BTS website. And this medal will be awarded at the BTSYM conference later this year. And next slide. So the next one then is for the BTS annual gala dinner. This year, this is being hosted on the 6th of May. The bookings open in February, so look out for that. Tickets are £130 per person, and there is a concession rate for BTS young members and retired members. And just as a reminder for all of you who booked and paid for the 2020 BTS dinner, they're already in the pot for this event. So further details will be available shortly on the BTS website. So I look forward to seeing many of you there. It will be a great one to be able to celebrate with you all in person. Next slide. So the next one is a reminder. So the BTSYM conference is now on the 22nd of May. The 20th of May 2022, I've just been told, so just a slight update. So again, if you look out for details, and the application link will be available on the BTSYM social media pages. Next slide. And then just a reminder for those of you that haven't yet checked them out, 𝗦𝗽𝗲𝗿, who will be joining us at the BTS dinner this year, prepared for us last year a number of tunnelling songs to celebrate the 50th anniversary. So if you haven't checked them out yet, the bit.ly link is available in this slide pack. And again, a reminder for those of you that are here with us every month, we're getting very close now with the book, and pre-orders will open in spring 2022 and publication will be due in this summer. However, still a number of stories yet to, but we are almost there. So as you can see, it's quite a tome, but it's fantastic to be able to collect all the stories from this industry. Next slide. And just as a reminder, if you have been thinking about coming forward and sponsoring the book, there is still time. So please do get in touch. And that's it from me this evening. So I look forward to seeing you next time. Thank you and good night.